Today we're going to look at section 10.7, volume and surface area. So three-dimensional objects. In geometry, three-dimensional objects are called geometric solids. Surface area refers to the flat surfaces that surround the solid and is measured in square units. Volume refers to the space inside the solid and is measured in cubic units. So imagine that you have a flat surface, a square flat surface with width and length. Adding the third dimension adds depth or height, depending on your viewpoint, and now you have a box. One way to view this concept is in the Cartesian coordinate three-dimensional space. The x-axis and y-axis are, as you would expect, two dimensions and suitable for plotting two-dimensional graphs and shapes. Adding the z-axis, which shoots through the origin perpendicular to the xy plane, and we have a third dimension as in the figure here. To study objects in three dimensions, we need to consider the formulas for surface area and volume. For example, suppose you have a box with a hinged lens that you want to use for keeping photos, and you want to cover the box with a decorative paper. You would need to find the surface area to calculate how much paper is needed. Suppose you need to know how much water will fill your swimming pool. In that case, you would need to calculate the volume of the pool. These are just a couple examples of why these concepts should be understood, and familiarity with the formulas will allow you to make use of these ideas. So first up, we have a right prism. A right prism is a particular type of three-dimensional object. It has polygon-shaped base and a congruent regular polygon-shaped top. So the base and the top are the same shape, same size, which is connected by the height of its lateral sides as shown in the figure here. Figure here. The lateral sides form right triangular prisms, octagonal prisms, and triangular prisms, and so on. So the formula. Formula for the surface area of a right prism is equal to twice the area of the base plus the perimeter of the base times the height. Where B is equal to the area of the base. So this should be 2, not 5. Surface area is 2 times base, the area of the base plus pH, where B is the area of the base and top, and P perimeter of the base. Height is the height. Formula for the volume of a rectangular prism given in cubic units is equal to the area of the base times the height. So we have a rectangular solid with a width of 6 centimeters, a length of 15 centimeters, and a height or depth of 6 centimeters. Find the surface area and the volume. So I have this rectangular, which actually happens to be a square, and I have it twice on both sides. So the area here is 6 times 6, which is 36 centimeters square. So I have 2 times 36, which is 72, and that covers this and the opposite side. Now if we look, we have 15 by 6. This is also 15 by 6. And then they have corresponding the same thing. So we actually have 4 times 15 times 6, which in this case would be 360 square centimeters. Add them up and we have 432 square centimeters. That is the surface area. Now the volume, well, the volume is simply 6 times 6 times 15. Or the area of the base, which depending on what we call the base. We call this bottom one the base, it's 6 times 15, which is 90 times 6, which would be 540 cubic centimeters. This is surface area. Okay, so here we have find the surface area. Okay, so we have 5 centimeters by 4 centimeters. All right, that's one rectangle that's 5 by 4, which is 20 cubic centimeters. That's this one. Here, this is 7 centimeters by 4, which is 28 cubic or squared centimeters. And this back one is 6 by 4, which is 24 centimeters. So that gives me size. Now I need the height or the triangles. We have a height of 4, and we have this measure, which would be the base of 7. So with 1/2 base times height. But there's 2 of them. So it's literally just the base times the height, which is 7 times 4, or 28. Then we add all these up, 6, 7, 80, and we get 100 square centimeters. And that's the surface area. Okay, the surface area, I have 1, 2, 3, 4, 5, 6, 7. I have an octagon, so I have 8 sides. You have 2 times the base, the octagon. Oh, so that's how they're doing this. That's 8 times the perimeter, which in this case would be 3 times 8, 24. This don't make any sense. Let's look at it this way. So I have 8 times a 10 by 3. I have, this is 3 inches or centimeters. This is 10, and it's a rectangle. And I have 8 of them. That's 8 times 30, which is 240. Then if we recall, if we, re- the area of our polygon is 1/2 a p. A is 4, p is the perimeter, which is p equals 3 times 8, which is 24. So this is 1/2 times 4 times 24. And that's just of the top or the base. Equals 2 times 24, which equals 48. Then we have two of them. So we have 240 plus 96 equals 336 centimeters squared. This is surface area. To find the volume, we simply take the base, the area of the base, which was 48, times the height. Volume equals base times the height. The base area was 48. The height is 10 80 cubic meters. Roof measuring 12 feet wide and 25 feet long, and it's 8 rectangular solid, 8 feet high, 8 long, 25 feet long. Yeah, this. Okay, we are back. So we have these two ends here, 8 by 12 or 96 square feet. Then we have four rectangles that are 25 by 8. 1, 2, the back and the bottom. So we have 25 by 8, which is 400. We have two of these. That's 192. And we have four of these. That's 1,600. We have 1,792 square feet is the surface area. And that's what we want. Next, we have right cylinders. There are similarities between a prism and a cylinder. While a prism has parallel congruent polygons as the top and the base, a right cylinder has a three-dimensional object with congruent circles as the top and the base. The lateral sides of a right prism make a 90-degree angle with the polygonal base, and the side of the cylinder, which unwraps as a rectangle, makes a 90-degree angle with the circular base. So, formula for surface area of a right cylinder is given by 2 pi r squared plus 2 pi r h. And the volume is simply pi r squared h. So let's find the surface area and volume of the cylinder. So the surface area, as our formula states, 2 pi r squared plus 2 pi r h. Well, we have 2 times pi times 7 squared plus 2 pi times 7 times 5. This is 98 pi plus 70 pi, 168 pi. Bring it up on the calculator. Now 168 times pi is roughly 520, and we'll round up to 28 square centimeters. So that includes the top, the bottom, and the wrap around. Now we want to find the volume. Volume is simply pi r squared h, which is pi times 7 squared times 5, which is 245 pi. 245 times pi, and that gives us, again rounding up, 770 cubic centimeters. Okay, so what about applications of this? You have 25 feet of rope to section off a rectangular shaped garden. What dimensions give the maximum area that can be roped off? Okay, you have 25 feet of rope to section off a rectangular shaped garden. What dimensions give the maximum area that can be roped off? So we're talking about a rectangle, and we know that the perimeter must be 25. So how about we try, what if we try, well, 5 and 5, 7.5, 7.5. What's that give us? 7.5 times 5. This would give us 37.5 square feet. Look at another possibility. Um, we go 6, 6, 6.5, 6.5. So we're looking at 6.5 times 6, which is what, 38? Let me double check that. 6.5 times 6, 39. This was 5 times 7.5. So it's looking like maybe, what if we go a square? And I know my drawing is not a square. Or every side is 6.25. So now my area is 6.25 times 6.25. And that gives us 39.0625. So that's a little bit more, not a whole lot, with such sparse numbers. So we're looking at a 6.25 by 6.25. The square, as far as a rectangular shape, is the best way to go about maximizing area. So suppose you want to build a container to hold 2 cubic feet of fabric swatches, but to cover the container in laminate costing $10 per square foot. What are the dimensions of the container that is the most economical, and what is the cost? Well, I'm guessing our square would be the way to go, or our cube. So all our sides are going to be the same. So volume equals essentially the length of a side cubed. So 2 equals the length of the side cubed. We take the cube root of both sides. 2 to the 1 divided by 3. Now we can do this on your calculator. We do 2, hit your caret button, open a parentheses, 1 divided by 3, and that should give you essentially 1.26, rounding up. It's 1.25992105. So we'll call it 1.26. So each of our sides is 1.26 feet. So I have 6 sides, all of which are 1.26 feet by 1.26 feet. 1.26 times 1.26. And then I'm going to multiply that by 6. So I get 9.5256 square feet of material. So this is our most economical is 1.26 feet a cube. What is the dimension of the container and what is the cost? So we need to multiply this by, and we get 95.26, $95.26. And that finishes our section 10.7. That volume and surface area.